Uh, yeah, let me just start with this equation, like the way it is. Let's start with this one, the uniform convergent. This uniform convergent. Here's the question that I wrote here. Remember the uniform convergence. Since well it was 5 marks. I think this one it was 5 marks and 5 2. I will just skip this one. I will do this 2. So since well you have 5 marks of this equation, remember you just have to find the pointwise limit, which is this guy here. We call this guy the pointwise limit. So remember you just have to write it nice as it is. You won't even jump any step. So please write it like the way it is, so that you can like get marks. Even if they give 3 marks, you'll be the one who is getting 3 marks. So here's the thing here. So I just wrote everything like this. Then remember I said when you put infinity here where there's n, when you put infinity, remember this is x. So x, it's an element of any number. So x, it's an element of real numbers. It means it can be any number here. So if you put any number here, you will get 0 irrespective of any number that you put here. Put 4, 5, 6, -2, negative half, fraction, ratio, or any number that you put here, you'll get 0 irrespective of what we put. So it will be 0 for any number of x that is in that, what is it, real numbers. Then since when you get 0, I said you have to find the uniform convergent. What does the uniform convergent says? It says the f of n, I think, is it double? I don't remember. Is it the double n, the double or the single? Let me just put the double. It's fn minus f is equals to the supremum of what? The supremum of x that is in that interval. We don't know the interval. Then it's what? It's f of n minus f. You see? Then remember this thing here, you can just write it like this. It must be positive, this thing. Whatever it's in here, it must be positive. So remember the supremum is the highest number of that interval that is in R. Remember that is in real numbers. Then remember here it's just x over 1 plus nx squared minus 0. You get? Share you get, yeah. It's Nigerian. They said share you get. Like share you get, it means do you understand? Yeah, share you get. So yeah, I think you understand this part. So you'll be left with the supremum of x that is in R. Then you have something that we call what is it? Let me just write it like this. X into 1 plus nx squared. You have this thing. So if you have this thing as it is, remember this R, you just have to put it where there is x. Remember here it's R, it doesn't have an interval. So since well the denominator, remember we have numerator and denominator. So the denominator is higher than the numerator. You see? Since they are higher than the numerator, you just have to find the derivative of this equation. So you'll get the derivative of this equation. Yeah, x over 1 plus nx squared equals to what? Equals to 0. Then when you find the derivative of this guy, what you're going to do is to use the quotient. Yeah, I'm right. So the quotient says derive the upper, which is 1, then leave the bottom, minus leave the top, derive the bottom. Then deriving the bottom, you have nx squared equals to 0, because it will be divided by 1 plus nx squared over squared. When you cross multiply, this thing will go, so you'll be left with a numerator only. So when you have the numerator, it's nx squared minus 2n. You see, it's 2n this side and this side. Oh, sorry, here I made a mistake. So it's 2nx squared equals to 0. I made a mistake there. I think you have seen that mistake. Then you'll do what? You'll cancel. So it's 1 minus nx squared equals to 0. Then solving for n, it's nx squared is equals to 1. Then x is equals to 1 over the square root of what? N. Because what? Because when you are here, it will be like x squared is equals to 1 over n. Then x is equals to plus or minus the square root of 1 over n. Then square root, you'll be left with this thing. You'll be having the square root of this thing. Then you can take the positive and put it where there is this thing. Where there is x, you put 1 over the square root of n into 1 plus n into 1 over the square root of n. You see? Then all squared. Then squared, they cancel. You'll be left to here. You'll have n 1. So you'll have 1 over 2n. You'll have 2 square root of n. This is how you'll be left with this thing. I don't know if maybe I should I should explain more on this thing, or how did I arrive here. Net, I'm looking at the time, so maybe I'll have probably my 2-3 videos. So let me just explain so that the aim is to understand, is not to finish. So it's 1 over the square root of n. I think you understand that part. Then here it's 1 plus n. It will still be here 1 over the square root comes the squared comes inside. When it comes inside, you'll be left with n here. Then the n cancel with the n. You are having what? 1 over the square root of n over 1 plus 1. You see, 1 plus 1 is 2. Then you'll have 1 over the square root of n over 2. Then the 2 will come here. Why does it come there? Because remember, it says 1 over the square root of n divided by 2. Then if you want to remove the division, it's 1 over the square root of n times 1 over 2. Then when you cross multiply, it's 1 over 2 the square root of n. So let me just erase everything. Then you know how I got those answers. Then let me just erase this part here. Erase, so that you can show deeper what you understand. You can't write things that you don't understand. So you just have to write square root of n, 1 plus 1. Then you just say 1 over 2 square root of n. Then you know what this thing goes to 0 as n goes to what? As n goes to infinity. Therefore, the f of n is uniformly convergent. Then f of n is uniformly convergent. You are done. You're done. Then let's go to second equation, term by term. So I think I will do one video, pause, do the other one, pause, do the other one, pause, do the other one, pause, because it says 10 minutes. So I'll just do one video. So you see, then I will erase here, because I just wanna write starting from this equation here, you see. So yeah, let me just pause this one. Then I'll see you in the next video.